In this lesson, we're going to learn how to determine the empirical formula if given an empirical formula and the approximate molar mass. The empirical formula of hydroquinone, a chemical used in photography, is C3H3O, and its molecular mass is 110 AMU. What is its molecular formula? Remember that multiple compounds can have the same empirical formula, and the experimental data which leads to the empirical formula doesn't necessarily tell us the actual chemical formula. But with the approximate molar mass, we can find the actual chemical formula. First, we're going to look at the mass of C3H3O. We have 3 times 12.01 U equals 36.03 U for carbon. 3 times 1.008 U equals 3.024 U for hydrogen. And 1 times 16 gives us 16.00 U for oxygen. We add these together and get 55.05 U. Now we're going to compare that value to the approximate molar mass that was given in the problem, 110 AMU. If I take 55 and multiply it by x to get 110, I'm trying to determine the value of x. And what I find is that x equals 2. Whatever the value of x is the same thing that I'm going to multiply the subscripts in the empirical formula by. So the chemical formula for hydroquinone is C6H6O2. We compare the values to figure out the multiplier. Again, whatever we multiply one subscript by, we must multiply all the subscripts by. Let's look at another example. A major textile dye manufacturer developed a new yellow dye. The dye has a percent composition of 75.95% carbon, 17.72% nitrogen, and 6.33% hydrogen by mass, with a molar mass of about 240 grams per mole. Determine the molecular formula of the dye. Note we were given the molar mass in units of grams per mole, and in the previous problem we were given it in atomic mass units. The numbers are the same, so the multiplier will be the same. It doesn't matter which one we're looking at. First, we need to go through the process of determining the empirical formula of a compound from the percentages. We're going to assume a 100-gram sample, which means we can convert the percentages directly to masses of each element. Next, we need to convert to moles for each of them using their molar mass. And we get 6.32 moles of carbon, 1.26 moles of nitrogen, and 6.28 moles of hydrogen. Now we need to divide by the lowest number of moles, and we get 515. We can now write our empirical formula because we get whole numbers. We don't have to multiply anything here to get to a whole number. And we have C5H5N. Now we need to figure out the chemical formula or the molecular formula because we have an empirical formula here. If I look at the mass of this compound based on its empirical formula, I get a mass of 79.10 grams per mole. I need to take 79.1 times x and set that equal to 240 because that's the approximate molar mass. When I do the math, I get 3. Therefore, I know I need to multiply each of the subscripts by 3 in order to get to the chemical formula, which is C15H15N3.